Yes, previously we successfully deployed application, right? Angular application. And what about you are tried, right? Is anyone face any issues or any error commission issue? Anyone face? All are right.
Sir, no, I'm yet to practice, sir. So if I encounter any issue, I'll let you know.
Okay, okay. What about others? The given task is completed, right?
Yes.
Okay, fine.
So, is
Yes.
my voice audible enough?
Yes, fine.
Okay. So, one quick question. So, we had two classes on the Elastic Kubernetes services, right? So, the first class we created a cluster,
Yes,
and second class we used deployment scripts.
yes.
So, when you deployed the deployment scripts, did we use the same nodes that we created on the first class?
No, 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 no.
No,
In
no, right? Okay, okay.
first
That's it.
class
That's
we
it.
just first class we just
That's all.
deploy. Okay, okay. And you got the scenario, right? First class we set up the cluster with two node, right?
Correct.
Then we delete that cluster. I mean, I also delete the cluster. And
Yeah, that much I practiced, but yesterday's we did not. So uh, we thought of doing today or tomorrow. But when we do, I can start fresh on a new EC2 and just create run these deployment scripts, right?
yeah, sure. So here you can see this is my cluster. My screen is visible, right? Get node. So here I have three nodes inside my Kubernetes cluster. Okay, three different nodes, and this is you can see that three nodes in our instance dashboard. These are the three nodes. Okay, here it will automatically fetched when we set up the EKS cluster. Okay, so okay, so some other key points we need to cover. Okay, today that is namespace, right? Kubernetes. Okay, one is namespace. And cluster IP. These are under service, okay? Services. Then node port. for load balancer. Then there is two way we can deploy our pod. Okay, anyone know what are the two way? Any idea?
kubectl.
No. I mean deployment types. Deployment types.
Minikube.
Minikube we will cover today. Yeah.
Okay.
One is declarative. The second one is imperative. These are the two way we can set up our pods, containers, services, all things, okay, inside the Kubernetes cluster or in Docker environment. So what is declarative and what is imperative? Any idea? Anyone? So we already done that declarative part. This declarative is nothing. We create a deployment YAML, right? This is our YAML page. Deployment.yaml. These types of setup is called declarative. Okay, so in declarative, yep. Inside the declarative mode, inside our YAML, we specify all the things, right? For example, creating with the API version, kind, our name of application, under spec we mentioned the replicas, and yep, container images, all things we provide here, right? And this way is called declarative. Then what is imperative? Imperative is nothing. We didn't go with any YAML file. Directly we deploy our application. Got it? In that case, for example, kubectl. We didn't have any YAML, okay, YAML or anything. We just set up the cluster. Then we can directly, using a single line of command, we can deploy our application. But inside the single command, we mention everything. Kubectl create. So this will create a pod directly, okay, with the container. I mean, with the image. Kubectl create deployment. Then the name, okay. Name is, this is for a Nginx web server. We can set up the Nginx web server inside a container. Nginx or Apache. Nginx deployment. Then this is a name, okay. Then we need to specify the image, right? So that it will create a container with the image. So image is equal to Nginx. and the version latest. Then we need to specify the replicas as well. Okay. So how many replicas we need for this application, and we need to specify under the replica. Replicas equal to, I will go with the 4. Okay. So this is imperative, and here okay, and take a sample. Yes. This is what? Declarative, and this is imperative. So you got the point, right? These are the two approaches we set up our deploying our application in Kubernetes or in Docker also. Okay. Even we didn't go through any Docker file or anything. And for example, we need to run a Nginx container inside a Docker. We can just pull the container, run the container. That's called imperative way. Got it? Everyone? There is now port, and we need to, sometimes we need to getting all ports, we can dash capital A. So it will shows all the ports. These are the ports. These are the default ports, okay, running some application for running the Kubernetes. And so here nothing, okay, there is, yeah, some files there. But don't bother about that. We can go with another KDA. Yeah, I'm just going the directory, that's all. Now here nothing, okay. Ls, nothing. So now I will show you simply how to run a Nginx web server inside a Kubernetes cluster, okay, using imperative way. So directly using kubectl create deployment, and I need to mention the name of the deployment. Then here I am using Nginx deployment. Then I need to specify the image name. This is visible, right? I mean, font size.
Sir, I think the spelling of deployment is wrong.
Okay. No need, because this is just a user name. Okay. And deployment. Okay, fine. Then we need to specify the image equal Nginx. Here we need to specify the correct spelling, because when we are running this imperative deployment, okay, it will automatically pull the image under where the Nginx image located. I mean in Docker Hub, okay. So it will automatically pull the image and run the container. Latest. Then the replica. replicas equal. I am giving 6 replica. Hit enter. Okay, now the deployment.apps Nginx deployment is created. You can just using show that using kubectl get port. You see, so we have now 6 pod. In each pod there is a container application that's run the Nginx web server. Okay. So here we didn't write up any YAML or anything. We directly pull the image and using that image we create what? Create the container. Got it. Any doubt?
Can you explain the command for us? It's a little bit long. Can you explain it for us?
Just nothing. Just first we using the kubectl command. Then we say to the kubectl, okay, we need to create what? This is a deployment. Okay, deployment name, Nginx deployment. And we need to reserve image where the image belongs. Okay, here this image belongs to a Docker Hub. Okay, it will automatically pull the image when we running the command. And yeah, this is image. This is Nginx latest. They will pull the Nginx latest. And the replicas. Replicas is how many containers we need. I mean port, not container. How many port for our deployment?
6.
6, right? Got it.
Yes.
I have a doubt. So there is declarative and imperative. So on the same cluster, we can use both types of deployments.
Yes.
Okay.
No. No.
Yes.
Take.
So this is our single deployment. The deployment name is Nginx deployment. That we specify here. Got it.
So
And
can you explain when shall we use declarative and imperative?
most probably we are going with the declarative because we need to create big size YAML files. Okay. For example, for multi-container or inside a YAML, we specify different containers and images. So most probably in a big organization or a mid-sized organization, we go with the YAML file. So we can edit the YAML file and all things. This is for a test purpose, we can go with the imperative way. That's all. Because we didn't record anything for this case. Right? For example, we need to deploy a web server. So we can directly go with the imperative way. We didn't save the YAML for this single type of scenario. Okay. And coming to application deployment, we need to go with the declarative way because we need to file all things. I mean the YAML file. For example, we need to customize the application, right? So we just go to the YAML file and edit the things, and again we need to apply. That's all.
Okay, thank you.
Okay. And now we cover. Yes. So this is done. And we need to learn what is namespace. Okay. So anyone have any idea about what is namespace? Namespace. namespaces is actually it's a logical and virtual cluster actually, okay, within a physical Kubernetes cluster. And it is a way to partition and isolate our resources and object within the cluster. For example, for using namespace, we will get some features called resource isolation inside our cluster. For example, we have 2 clients. Okay, so we need to create different namespace for the 2 clients and deploy their application. So that is called a resource isolation. Okay, that namespace allows us to create multiple virtual cluster or environment within a single physical Kubernetes cluster. And isolation is one of the main thing. Then access control. For example, how can we say, if we have a multiple teams, okay, working on a different application within the same Kubernetes cluster, so we can create separate namespace for each team to keep our resources and configuration separate and manageable. So it's actually namespace is a fundamental concept in Kubernetes. So it will contribute to better organization like resource isolation, access management, access control within our cluster. So how we will go through the lab? First, we need to create a namespace. So as of now, we can see these are the, there is one default namespace there. Okay. We didn't create or we didn't mention any namespace in our deployment. Our all deployments are under the namespace. So we'll check using kubectl. Same command, okay. Kubectl get pod. Okay. Then we need to mention the namespace. -n for namespace. And our name, I check, okay, that our deployment is under the default or not. You need to mention the name of the namespace. Here our namespace is default. So that 5 pod, okay, that 5 pod under the default namespace, right? Because I didn't mention any namespace or I didn't create a namespace here. Got it? Get it out? So I will just delete the deployment, okay. How to delete? I mean, I need to delete this pod and even the deployment. So just delete the deployment, okay.
I have a question. So
Yes.
we need to create a namespace, or
Yes,
if we need to create,
first we need to create a namespace and we need to mention that namespace so that it will create under that namespace. I mean, our deployment is under that namespace.
So when are we creating this namespace? When are we going to create this?
And you mean the scenario or?
No, if we need to create a namespace, what is the appropriate time? Like when shall we do that? Before deployment, or
Yes,
when shall we do it?
before deployment.
Can you please show that command? How can we create?
Yes, I'm going there actually. Yep. So
Okay, thank you.
yeah. So you see here, before that I will show some other thing. Like here you can see I have 6 pod, right? You see 6 pod. So I am just delete one of the pod, okay? So what are the commands to delete a pod? kubectl, ctl, delete pod and the pod name. Here this is one of my pod, copy, paste here, hit enter. So here pod 1 is deleted, right? Out of the 6. So how many pod that now I have? Anyone?
5.
5.
5. What about others? Here you see our replicas is 6, right? So the Kubernetes knows everything because our desired, the replicas means our desired state. Okay, we can call it as the desired state. If any pod deleted, the Kubernetes will automatically create that pod. Got it? I will check that thing. Sure. See, 1, 2, 3, 4, 5, 6. Got it. So which is changed? We can check. Okay, G5 is here. Yes, which one we delete actually? FF we deleted. So the FF is not here. It will create another one with HJ7. So we can directly delete the pod, no issue, because sometimes we are, for example, this pod, okay, this specified pod integrate with any other pods, okay, or any other container. So sometimes the communication is stucking or anything happen because the communication not happen. So that we can just delete the pod, then it will automatically recreate the pod and the communication is same as before. So different scenario we can delete the pod. So because our state is here, our replica state is 6. That's why it will create and it will ensure that we have the 6 pods. Okay. So that's all. And yep, we need to show our deployment. Yes. So I'm going to delete the deployment. If I need to delete the entire thing, for example, that I need to delete that 6 pods and the deployment. Okay, just I need to delete the deployment. So it will automatically delete all things. So the command is kubectl delete deployment. Okay, this is deployments. Okay, so that I need to specify the deployment and the deployment name. Here the deployment name is nginx deployment. Hit enter. Now it's deleted. Okay, now I need to check the pod count and things default. You see nothing there. Only the system kube system containers and pod. I mean, sorry, not sorry, pod. Okay. So now I am creating a namespace. Then I will redeploy the same thing under the namespace. Before you see, by default, it will go to the default namespace. Okay. So how to create a namespace? Same command like kubectl create namespace. Then the namespace name. Okay. Here our namespace name is web server. Okay. Hit enter. Now there is a namespace called web server is created. This we can check. Get NS. You see, we have one more namespace there. That's called web server. And we can check under the namespace any pod are running. Just kubectl get pod and the namespace web server. Hit enter. No results found in web server namespace. Okay. So the same command we are going to deploy again for the nginx. That is kubectl delete. Yes, you see kubectl create. I'm going to create another deployment. I mean the same deployment for the nginx, and the deployment name is nginx deployment, and image is nginx, and replica is 6. Okay, And after that, we need to specify the namespace. Web server. Check. See, now it's under our web server, right? And you check with the default one is so anyone will be default or not. You say ULT. Nothing there. So this way we create a web namespace and deploy the application under the namespace. Got it? So in my case, I have kubectl, ctl, get node. How many nodes I have here? 3 nodes. Okay. So under these 3 nodes, I deploy the 6 pod, right? Anyone have any doubt? Regarding namespace? Now we can say these deployments, I mean, these containers are isolated because these are in the web server namespace. So these resources are isolated. Otherwise, all things are messy, all are grouped with each other. So here we are creating a separate namespace and we move that deployment, I mean that containers with the specific namespace. Again, we can create another namespace or another thing, for example, application, front-end application or database. So each things we create different namespace and keep that resources and keep that deployment with the specified namespace. So these here there is 6 containers, I mean 6 pods inside these 3 compute engine or these 3 EC2 machines. So each one have dedicated to any of these machines. I mean these node. Okay, that all things will manage by the Kubernetes master part. So using kubectl get port 0 byte. This will shows the all details for the ports. Okay. We need to mention the namespace and web server. You see, these are our ports and these are our nodes. Okay. For the case, this port, okay, this port belongs to this machine. I mean that 52, right? Actually, we have 50. How many machines? 52, 243. I mean the last private IP. Okay, just for the quick key, and 199. Okay. So first port is go to 52. The second go to 199, and third port go to 199 again, and the fourth one is go to 243, and the fifth one is allocated with 52, and the sixth one is 244. Got it. So these are the way they, I mean the Kubernetes master part and the schedule are allocated for that each mission. And these all are the replicas of the same application. Remember that. It's a single application and its replicas. Hello. Your voice is not clear.
Any mama baby, or say any mama baby. Mama Antoya, you follow Mama Antoya. I don't know where you're at. I did that sort one in
Coffee, coffee.
Yes, I
mute yourself.
Yeah, I mute. Okay. So Yes. Then cluster IP in services. Okay, coming to services. Some other terms like cluster IP, nodeport, load balancer. Okay, so we need to learn each thing. Okay, for a better understanding. Because coming to interview, we need to specify all the things. So what is cluster IP? Cluster IP, these are all our services, okay, under the service. Got it? So service means first week, for example, we need to deploy an application. Okay, I will show you. Here, I am again go with the declarative way, okay, okay. And just delete the thing, I mean end everything. kubectl. Or we can leave this thing, okay. Nano deployment. Deploy. YAML. Hit enter. And yes. Okay. So this is my deployment, okay. Kind is deployment. And name is this is the name, okay, 2048 deployment. And the application name is 2048. The replica is 5. I don't need a 5 replicas. I just change that thing. I need only 2. Then yes, coming to containers, there is an image. And yeah, coming to port, 80 is exposed. That's all. Okay.
Can we specify namespace in the deployment file?
Yes, I will create another namespace kubectl. This is a small size game, okay, so I will create a namespace called in the game. kubectl create.
Can't we specify in the deployment file?
No. I'm just, you mean inside the namespace, right? Inside the deployment file.
Yeah.
Yes, it will automatically fetch up the namespace if the namespace is there, or it will create the namespace along with the when we applying the deployment file. Got it.
I have a question like, what is the readiness gates?
Sorry.
Readiness gates in the above command. So it is showing all the details of the parts, right? So in the end, there is a
You
column.
mean this thing, O wide minus O wide.
Here in the result, in the last column, it is showing readiness gates in the last column. That command, yeah.
Yeah, readiness, right? This is readiness and low.
Sorry, readiness, yeah, I couldn't see.
Yeah, we didn't mention these things. I mean, for this case, readiness
Okay.
and liveness. These are the two things of Kubernetes. Okay, that is for some case we need to monitor our port and the communication. We need to ensure the communication with each one of the ports. So we configure that things in readiness and low liveness. These are the two parts. Yep. So here the namespace name is game. I have the deployment, yes. So kubectl apply, right? Because we have the deployment file. And you need to mention the file name. File name is deploy.yaml. And we need to mention the namespace as well. Okay. Our namespace is game. Hit enter. Done. See, both are running. Copy. And this is all service, okay. And yeah, here we show the cluster IP, not port and load balancer, okay. So cluster IP is it's a type of service for expose an application internally within our cluster. Okay. For that scenario, we use cluster IP. We didn't expose that application outside our cluster, only for internal communication. So it will assign a stable IP address that in order, it's assign a static IP address for our application within the cluster. Okay. So we can use to assign the service, the cluster IP service. And most probably we are using cluster IP, used for internal service, inter-service communication. Got it. For now, we are exposing our application. Okay. So exposing application using two ways. One is nodeport and the another one is load balancer. So both are exposing our application with a different scenario. Okay. Then why we choose nodeport? Nodeport, actually nodeport is a service type that expose our service or application on a static port on each node IP address. Okay. Coming to this is our node. And inside our node, there is a pod. Inside our pod, there is a container. Okay. So our pod have an IP, right? Our node have one IP. Pod have IP, node have IP. This is node, this is pod. Okay. Node. Pod. This is a container, okay. So the container also have IP. Got it. So we specify each thing. Yeah.
Container IP should be same as pod IP, right? They use same IP, right?
No. Because, for example, in a single node, okay, inside this node, there is one, consider there is one more pod, okay, and one more container there. So this will make messy, right? For example, this pod have 1.1 IP. Consider, no, this is not IP 1.1.1. This is IP of this pod, okay. This is another pod. Got it. So each one have different private IPs for communication. For example, yep, this is a node, and inside the node different pod. Okay, So sometimes this container talk with this container, right? So if in case if this container have the same IP and this have the same IP, how they talk? So each container and each node have different IPs. All IPs are private IPs, okay, and the IPs are allocated with by default. It's all managed by the Kubernetes. Sometimes we need to customize this IP. We need to mention the YAML file for all things. I mean the port, container, all IP we can mention. That's a complicated YAML file. Got it? Any doubt?
No.
Okay. And these IP addresses are for, it's essential for communication between pods and containers within the Kubernetes clusters. Okay. So, yes. Now we are talking with the custom. We are discussing cluster IP, right? Yeah, cluster IP for internal communication inside the cluster. Okay, consider this is a cluster. This is a cluster. And we mention in our service file, the type is, I mean, this is a type, okay. First of all, I create a namespace. Not namespace. And the name there, then nano. Okay. Copy the thing. And here you see this is a node port, okay. So here under type, we need to mention which are the service we need. If the thing is cluster IP or node port or load balancer. So cluster IP we are mostly using for internal inter-service communication inside the cluster. And coming to node port is a service that exposes our service or application on a static port on each node IP address. I mean, for example, this means that we need to access a service. Okay, so using any of the node IP address and the specific node using the node port, and mostly it will useful when we need to access the service externally within the cluster. So here the problem is that our application is not load balanced. Okay, for when we use node port service, for example, we set up the application or set up the deployment, and for test purpose we can choose the node port. For a front-end application, for example, a internet-facing application, we are going with the load balancer, and the load balancer we use to expose our application to external world. Got it? Through a cloud provider load balancer, because when we creating elastic Kubernetes service, okay, using first we creating Kubernetes service, right? At the time, the load balancer is automatically created. Did anyone mention that? So here in deployment, I mean in the service, if we mention the load balancer under the type, it will automatically using that load balancer for load balancing. And the cloud provider or this Kubernetes automatically provision the external load balancer and assign a public IP address to routing traffic to the service. And most probably we are using load balancer for public facing application. So here I am using a public facing application like 20. And I need to mention load balancer. And you see if the node port names like first N is capital and port P is capital. So we need to mention, we need to ensure that, for example, load balancer look like this: load, again, L is capital, and the B is also capital, balancer. Otherwise, it will we will face some error when playing. This is fine. And yes, I need to apply. So I need to check kubectl. How we check the services? Get what? Anyone?
SVC.
So get service, right?
Yes. So you see, here we got one external IP. Got it? This is here. See, this is a cluster IP, okay, for intercommunication. So there are public IPs for intercommunication. I mentioned the load balancer, okay, in service. That's why it will show. It will create the load balancing, URL for accessing my application. Just to copy, paste. It will take some time because it's routing, the load balancer setup, all things we need to ensure. So meantime, we can go with another topic. Okay. So Minikube. Quickly, we can take the Minikube section. What is Minikube? Minikube. Anyone know what is a Minikube? Anyone? Any idea? No idea. Yeah, following, right?
Yes, we are following.
Yep. Now we are set up a Kubernetes cluster with multiple nodes, right? We previously I created a Kubernetes cluster with 3 nodes. We using 3 to EC2 machines. Got it. So this is a production environment setup, okay? Like a full-fledged EK setup. So coming to the scenario or coming to real world, sometimes we set up Minikubes for test purpose. With this, using a single machine. Inside a single machine, we can set up a Kubernetes cluster. Okay. So that's where the Minikube stands. Minikube is a tool that enables to run a single node Kubernetes cluster locally. Got it? For example, in our machine, we have a local machine, so we can install Minikube in our local machine or in cloud machine or any machine. We just choose a single machine and deploy the single node Kubernetes cluster. And it's most suitable for the developers or sysadmins we are the IT infras to testing our application.
Unit testing environment.
No. For example, before we need to set up all things in the production environment, yes, like pre-pod testing and things like that. Okay. So Minikube is a platform we need to perform that Kubernetes cluster in a single node. Several features are there like local deployment, single node cluster, easy setup, and yeah, also Kubernetes features there. Okay. So first we this is also in scenario based. Okay, for example, say a big size application, so we need to test the application, right? I mean, testing locally. So we didn't go to the production environment. Before that, we need to test the application. So we create a Minikube and create the things and deploy the things in Minikube and run and test. If passed, we can go to the production. Okay. What about our application? Okay, so quickly I will show how to set up a Minikube. Create a machine. Minikube. Choose Ubuntu. And my keeper is choose client. I'm just enabling one more port. Okay, I have one React application, so just to deploy in Minikube. That's one with the 3000 port. Anyway, wait. Again, I'm opening another PowerShell. Then this is not EC2, Ubuntu. So default username is Ubuntu for Ubuntu machine. At the rate. I'm audible, right? Hello?
Yes, yes.
Tab package update. Before that, I need to install the Docker. Okay. Install Docker. Docker version. It's 24.1. Okay, fine. So yeah, there's a package for the Minikube. We need to install the Minikube. Yes. IP. Fine. Yes, because I need to mention a big size machine. So let's say stop. Sure, I will share. Now I change the instance type, okay, because this is I face some error here. You see, I mean, our memory is less for Minikube, so just change to T3. There is not T3. Yeah, going to T3 medium and apply. This is the way. This is called. Anyone know what I am doing now? Anyone? Are you following, right?
Scaling?
Yeah.
Scaling, right?
No. This is called scaling.
Scaling.
Yes. This is called, there is two types of scaling, okay? Horizontal scaling and vertical scaling. Now
This is vertical scaling.
Right. Now I've done vertical scaling. Okay. In coming to vertical scaling, we need to stop our machine and we need to upgrade our resources. This is my Minikube machine. Before that, I am running T3 small. Now I stop the machine and change it to T3 medium. Okay. Again, I need to start the machine. One of the drawback is we need to stop the machine. For example, if the machine is in production, it will make the thing, you know. Okay, I got the IP. And go back here. For horizontal scaling, we didn't bother about stopping machine. Okay, it will automatically replicate the same machine. One is resource scaling and one horizontal is the entire machine will replicate. So it will like multiply. Okay. Now I am, yes, this run. Yeah, now it's work. Now it's downloading the Kubernetes package, all things, downloading Kubernetes version 1.2.
While it does, can I ask a question? Can you show me the curl commands that you used?
Yeah, I will share.
just-
I will share the group.
We want to understand. You are trying to download a couple of
Yeah,
things.
this is curl.
I see.
Yeah, curl.
Yeah.
This is the thing I need to curl, like kubectl, right?
Yeah, but I see you are doing a curl inside a curl. So
No. This is a single curl Minikube. So this is for
no. Go to the above one. I see a curl inside a curl, right? You did curl and
here in terminal, or where you see that?
go to the notepad. Go to the notepad. Yeah. So the first line where you have curl hyphen l. Yeah. Wait.
Okay.
After release, you are saying dollar. One more curl you have.
In a single curl, we can run, multiple things. Okay. For example,
Yeah, the second
sorry,
curl, what you are trying to do?
this is release not. You can see this is a thing we actually downloading. Kubernetes release not release table text. Got it?
Oh, version. You are getting the version. Okay, releases slash version number, but version number you are getting dynamically so that you can go to the particular version number and go to bin and Linux. Okay, I understood now. Thank you.
So
Can you ping those commands in the chat?
yeah, I will. So here done. Okay, Minikube is done. So yep. I need to check the Minikube status. Cube. You see, Minikube is run and ready. Host is running, kubelet is running, API service is running, kubeconfig is running. Got it. This way we create Kubernetes. We can using the kubectl command here. Kubectl get node. I am just run a imperative way, okay, to deploy kubectl to-do list. To code. Yeah, now it's done. Okay. So kubectl get-pod. You see, one of the application is up and running in our Minikube. So we need to expose this application, right? So now I am doing with the nodeport, okay, in imperative way, like kubectl expose pod, then the pod name. What is the pod name here? To-do list app. Okay, then the type. Type is equal to not pod, right? Then the port is 80. This is which port? Container port or host port? Then we need to mention the service name actually. Name equal to-do list app service to any name we can choose, okay. This will create the service with this specific name. To-do list app service. So it will create a service connection kubectl get SPC. So you can see here, this is not port and the cluster IP is external IP, is not external IP. And now we are learn one more thing, because Minikube is in our host, okay. For example, this is our EC2 machine, okay, right? So inside the EC2 machine, we create Minikube. Currently, Minikube is a isolated thing, okay. Minikube. And the Minikube run Kubernetes, and inside the thing we create a single pod and a container, okay. But this machines doesn't know much about the a connection between Minikube. So what we will do is there is an application running, okay. In Minikube, there is a to-do list application. To-do list. But how we access the application? This is using for this case, we using a port forward command, okay, kubectl port forward. And why we using port forward command is we just copy the this application to our local machine. Here our local machine is EC2 machine. Got it. So this is mostly for the test cases. Okay. For example, our application Kubernetes cluster, even the Kubernetes cluster in the cloud or on-premise or in the same host, we just running how we running the application in our local machine using port forwarding. Okay. So here I am going to port forward. The command is kubectl. This is the command, okay, port forward. SBC to do list app. Service. Then we need to mention the port of our local machine. Actually, this is called a port forwarding, okay? Like this is our machine, local machine or our EC2 machine. This machine have a IP. So here we need to provide in port forwarding, we need to provide the host machine IP plus this container IP. Okay, container IP is 80. And our port forwarding, our local machine, we need to, not the IP, we need to mention the port, okay, sorry. Port of local machine and the container machine. And in our case, I enabled the 3000 port, you remember, when we creating the machine. So here our local machine port is 3000 and the container port is 80. And who will access our application means anyone, right? So we need to mention here as before the address, in any IP is access our application. And we need to exit the thing, the terminal using the ampersand. Then done. Now it's forwarding. You see, forwarding to 3000 port. How do we access the application? Copy the IP. My application is not running. I'll just paste here and mention the port. See, so this is a to-do list application that's run in a Minikube cluster. There is no database, so just read up the thing. Add task. We can add task, but when we're reloading, the added task is removed. Why? Anyone know? I remove all things and just reload, all things came back. Anyone know why? Because we didn't configure or due to load database, okay? That's why. Got it. About the Minikube. Anyone have any doubt?
Yeah, a couple of things that you used in the commands, for example, type node port.
All good, right?
Yeah, I have a couple of questions. in one of the command prompts, you
All of
used.
you.
Can you hear me? Hello?
Yes, yes. I accidentally mute
Yeah,
my. It's my mistake. Yeah.
yeah. Can you go back to the other PowerShell? I think you have two open.
Which one? Minikube.
Yeah, so here you used node port, type as node port somewhere. See, kubectl expose pod, there is a command, couple of lines above. Kubectl expose pod to-do list app.
Hmm.
Okay, type node port. What is type? What is that actually?
This is the service part actually. The type that's we discussed earlier. I mean, these are the services.
Okay, okay. If I
These
look
are the
at the
big
service
three.
config, we will understand.
Yes.
Okay, okay.
In my
Oh, basically,
Minikube case,
I get
yeah.
it.
Okay.
I get it. By saying node port, you are saying it is a service config. Okay.
Yes.
Can you go back to the PowerShell again?
We can add this type in the deployment file also, right?
Here we are going with the imperative way, so we didn't have.
Right. Yeah. If you want to go as a the other way, other kind of deployment by adding in the YAML files, we can add that type as node port
Yes,
or
yes,
cluster IP.
yes. Like this is another file, okay, for the service. Here,
Yeah, in the declarative way.
Yes, declarative way.
Okay.
Here our type is not, but
Yeah.
we can change. Before I change this as load balancer for this case.
Can we go back to the second one? The other, yeah. So when you do expose, you are basically exposing the
Exposing
components port,
this
pods port.
pod. The pod name is
Yeah.
to-do list app.
Okay.
This is this is the one.
And
And
then
the
you are
type is not pod.
associating.
Sorry.
And then you are associating that with 3000 port by doing.
Your voice is breaking.
Now you are associating the pods port with the application port using the port forward command.
Yes.
CTL port.
Yes, yes, yes.
Okay.
This is for nothing. Our application here.
Port mapping.
Yes, we just clone up the thing in our local machine. That's all. So we can access our host IP and host port with the container port. This is like a forwarding, port forwarding.
Question. In the port forwarding, you have used 3000. How do we know that it is 3000 or some other number?
Yeah, I opened the port when I creating EC2. You remember that? Where it is? You see, I enabled the port number 3000. That's why I am accessing using that.
Can you wait? Can you go back once? And that too, it is a custom. Good.
TCP.
Yeah.
Custom
TCP, custom TCP. Yeah.
Yes. And it's for everyone. Everyone in the net can access the website. Copy. I'm pasting in chat. You just can test. Any doubt? Sorry?
Can you please copy the commands, share the commands?
For Minikube, right?
Minikube as well as and also, yeah, and also you had some curl commands to pull data.
Yeah, that I will share. And choose the machine as medium, okay, T3 medium. Otherwise, because the Minikubes have some prerequisite to run the base image. So we need to ensure that the base machine have much resources, the memory, CPU. That's why when we are starting the Minikube or downloading the Minikube, we face some error. So that case, we will cover the scaling, right? Horizontal scaling and vertical scaling. That's one of the major things in cloud computing, because one of the feature is these types of scaling. Okay, there is two types of scaling. One is called horizontal scaling. Horizontal scaling and vertical scaling. Vertical scaling. And we've done the vertical scaling, right? Because this is a machine. This is a virtual machine. Consider this is a virtual machine. This is also a virtual machine. So horizontal scaling means as per the requirement. For example, we deploy an application in this virtual machine and we configure all things. And when the CPU utilization is above 80% for this host machine, we need to scale up. Okay. So coming to vertical scaling, it will create the same identical machine with in underlying infrastructure, all things is gone. Okay. It's like create another virtual machine. That's all. For balancing the load. Okay. So the load balancer or anything behind this will routing the traffic to this. So this CPU will reduce the percentage, go down. Okay. So this is called horizontal scaling. In this case, the base machine does not stop or anything like that. Coming to vertical scaling, we need here what will happen means this machine have one CPU and one memory. Okay, RAM, not CPU versus CPU. Okay, so in vertical scaling, we need to add the resources, not the machine. Actually, we just stop the machine and we change the resources. Choosing the other type instance type. So we will get 2 vCPU and 2 GB RAM like that, or we need to choose as per our requirement. So in this case, we need to stop. Here we didn't stop because the scaling system will automatically spin up the machine. Here we got 2 machine. Here only a single machine. We add up the resources only. So these are the high level view and explanation of horizontal scaling and vertical scaling. Okay, yeah, our application is, this is our Kubernetes application. Okay, the previous application we deploy. This is a small size game. So using keyboard, we can play game. And this is our Minikube application. Okay, both are in Kubernetes. One is in production level Kubernetes and one is in Minikube. One is in a single node and another one is we are using 3 node, right? kubectl get node. Here we configure with the 3 node actually. Okay. Anyone have any doubt? Then we can bind up, right? Hello. All are there, right?
Yeah, yes.
Okay. So I will share the Minikube code and yeah, all the things, and we'll share the task for the weekend. Okay, just to go through that. And don't miss to take the labs, okay? Because if we in queue, keep in queue, it will, timely we can go with each lab. Otherwise, we have some confusion when if we are in trouble. Okay. Fine. All of you. Shall we wind up?
Yes, we're
Okay.
good.
Fine. Okay, bye then.
Okay, bye.
Bye.
Thank you.
I have one question for you, Tofik.
Yes.
You know, when I created my deployment, I show you that my I can see my container, I can only see my ports. And you asked me to show you my deployment, but I actually didn't know what was the problem.
Share the screen.
Or I should go over again and see when it happened again, then
Then we will troubleshoot later, okay?
okay, then next week. All
Yeah.
right. Thank you.